All right, we're going to talk about the domain of combined functions. Combined meaning when we add or subtract them, multiply or divide them, and composition. So first thing we got to review is domain restrictions. Now there are two main ones. You cannot divide by 0. And there can be no negatives under square roots. Now I use square roots as a general term. This is any even index root, meaning square root, fourth root, eighth root, anything like that. So to find the domain for each of these, for no division by 0, you take any denominators that have a variable in them, set them equal to 0, and solve. Then for any negatives under the square root or even index root, you're going to make an inequality with whatever is underneath the radical greater than or equal to 0. If it's not underneath the radical, it doesn't matter. Okay, here's an example of a radical. It's got variables in the bottom, right? No division by 0. So in this sense, what we're doing is trying to figure out what values of x would cause division by 0. So I'm going to take that denominator, x squared minus 1. We're going to make an equation setting it equal to 0 and solve, because that would tell me what values, when I plugged it in for x, would subtract 1 and get 0 on the bottom. This is an easy solve. Square root both sides, x equals plus or minus 1. So for our domain, there's a couple ways you can write it. Easiest way is to say something like all real numbers, x cannot equal plus or minus 1. If you were looking at it as an interval, it gets not pretty. Cannot equal -1, union. Everything from -1 to 1 cannot equal 1. U for union, 1 to infinity. I would either give you these type of problems, or you could write them in either way. I would accept them. All right, the second one. This has got a radical, an even root radical, right? Even number. This would hold true even if, like, say it was the fourth root of x plus 3. Same process. Take this stuff that's underneath. This time you're going to make an inequality towards greater than or equal to 0. That's all the positive numbers, right? Everything on a number line that's bigger or equal to 0 is positive. So this will help us figure out what x is. We'll keep that underneath the radical positive, or 0. So the domain of this guy would be you could simply say in inequality form, x greater than or equal to -3, or -3 to infinity. For this guy right here, this whole negative number underneath the radical, don't forget the golden rule of inequalities. If you multiply or divide by a negative number, the inequality switches directions. That makes a big difference when you're solving for this, because all of a sudden your answers change direction, and instead of from -infinity to 3, it would become 3 to infinity, right? Everything swaps. Inequality switches. Don't forget. Okay, so when we take combined functions and we join a couple together, it opens up a new domain, possibly. For example, here, f of x equals 2x squared plus 9x minus 1. That's a quadratic, a polynomial, whose domain is always all real numbers. So poly equals all real numbers. Now for this guy down here, This is a square root, an even index root, so we would have to take underneath has to be greater than or equal to 0. So your domain is literally going to be x greater than or equal to 0, or from 0 to infinity, including 0. So two separate ones, radical with even shelf number. Okay, get distracted. Okay, so when we start to add, subtract, and multiply these together, the idea is that you just have to find the domain that they both have, something that satisfies them both. So if we were to combine, let's say we did f plus g. What we'd look at is the domain of the first one you see. Okay, that's this yellow line. All real numbers, right? Here's a number line, everything to the left, everything to the right. And then it comes down to the g of x domain that says, okay, it's everything from 0 out to infinity. So if you look at that picture, you can see that inside that red box, this is what they have in common. That becomes the new domain. So the domain for the combined functions would be, again, x greater than or equal to 0. Or you can write it like this. That happens for all of the the combinations of functions, plus, minus, or multiply. The only one is that sometimes there's restrictions when it comes to division. So make sure you put a big note around this one, right? The domain for this guy is except where the denominator, the thing on the bottom, equals 0. We know that already, right? So let's examine this one down here if we were to put it on the bottom. So if I had f of x divided by g of x, in this case, it was 2x squared plus 9x minus 1 over g of x. Now, just the regular combined function domain would be x greater than or equal to 0. Well, for this guy, x greater than or equal to 0 would include x equals 0. But we cannot have x equal to 0 because it's in the denominator. No zeros in the denominator. So in this case, this fraction case is where it's going to become, where you really have to think about it. It's the division by 0 part that'll always mess up. So right here, we have this as our domain, right? Our combined domain, but x cannot equal 0. So what we do is take the domain we've got, and we take the possibility of equaling 0 out of it. So here would be the domain for these combined functions. Or you could have said open parentheses 0 infinity. And that only happens because the g is on the bottom now. So once you move stuff to the denominator, you got to be a little bit more conscious about what domain it produces. All right. Let f of x, blah, 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 find each of the following, and then state the domain of each. So first things first, I'm going to identify the domains of the individual ones. F of x equals 5x minus 6. That's all real numbers. That's the domain. Okay, g of x is 1 over x. His domain is going to be all real numbers, except x cannot equal 0 because that would put 0 in the denominator. Okay, here's the trick to these guys. F plus g, f minus g, and f times g are always the combined domains of those. For example, if I looked at a number line, right, boop, 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 here's 0. If I have a red domain here, that's all real numbers. If I put the green one for this, this is all real numbers except a big fat hole at 0. So what they have in common is everything over here and everything over here, which is the same thing as saying all real numbers, x cannot equal 0. Don't forget that not equal to line. That's important. So for f plus g, it's all real numbers, x cannot equal 0. F minus g, x cannot equal 0. F times g, x cannot equal 0. Then when it comes down here to f divided by g, there's a little bit more thought, right? We have to figure out where does g of x equal 0? Because whatever happens in that bottom, where does g of x equal 0? Well, here's g of x. Is there any number I can plug in for x that would equal 0? No, there's no way to turn 1 over x into a 0. It's 1 divided by something. It can't be 1 divided by 0. So this is not possible, which means this guy's domain is also going to be all real numbers. X cannot equal 0. It happened to be the same for all three of them. F plus g for these guys, f plus g would be 5x plus 6 plus, oops, minus 6. I paused, I knew something was up. Minus 6 plus 1 over x. Now you reviewed and learned that everybody had to have the same denominator, right? He's got an x. He doesn't have an x, so I'm going to multiply by x on top and bottom, which becomes 5x over x squared, sorry, 5x squared over x squared, sorry, x plus 1 over x, which becomes 5x squared minus 6x plus 1 all over x. Okay, f minus g, pretty much the same thing, except for now it's minus 1 over x. It's going to become 5x squared minus 6x minus 1 all over x. Okay, f times g, 5x minus 6 times 1 over x. Well, top times top, bottom times bottom, and that's it. All right, what about f divided by g? Anytime I divide by fractions, I write them out the long way. So f was 5x minus 6 divided by 1 over x. Now the rule for adding and subtracting fractions is that you multiply by the reciprocal. So this is going to be x times 5x minus 6 or 5x squared minus 6x. Now, notice that in f plus, minus, and times g, if you look at the final function right here, and here, and here, the domain makes sense for it, right? But when you're dividing two functions, when we divide them, does it make sense in this problem, at the end problem, the combined result, that x cannot equal 0? You can't see it at the end. You've got to see it at the beginning, determine the domain in the beginning before you actually work it out, because stuff starts to get canceled and moved, and it changes the actual look of the domain. So don't forget that.